Welcome, video example 12, Unit 2, Chemistry 1B. Okay, so we're going to calculate an equilibrium constant for the following reaction. It's an organic reaction. You can see there are only organic compounds present. Okay, so we need some extra information in this regard. So here is the table of information and the calculation for delta G. So we have some delta G of formation values given to us, and we can obviously use the reduced form of Hess's law with the thermodynamic quantity to calculate the delta G value by simply plugging in the values that are given in the table. There are only 1 mole of each, so it's pretty straightforward, and we see that the delta G value is a negative 64.28 kilojoules. Now this should tell us something about the value of K. Alright, so if the delta G is quite a high negative value, as you see it here, we're expecting a positive value for the equilibrium constant. So let's do the calculation so that you can actually see what I'm talking about. So again, remember we're using delta G is equal to minus RT ln K, and if we then take the antilog and rearrange, we get this equation here. Okay, so let's work out the exponent formula. Remember, this is the x value such that K is equal to e to power x. Okay, so we plug the values in. We have there's minus 64.28 kilojoules, and we have the gas constant in joule per Kelvin, and with the temperature, remember we have to do the conversion to joules so that the units cancel, and we're left with a sort of unitless parameter. All the units cancel. This negative value is now e to the minus x over here. So we put this into the equation, and we see that we can take the e to the power 25.94, and we end up with a K value of 1.85 times 10 to the power 11, which is a large positive value indicating that this reaction is highly favored, and that is substantiated by the delta G value being negative.